Oh, I forgot to start the recorder. But anyways, not much. So 5.3. It's regular. Polynomial long division is just simply regular long division with polynomials. Okay, and just to make sure we're all on the same page. Y'all remember this in like third grade? We did, 12 divided into 13,948. Something stupid like that. And, 12 times 1 is 12. Subtract it from 13 to get 1. Drop the 9. All that sort of stuff. That's basically what we're going to be doing, but with polynomials. Okay. Not as hard as it sounds, it's just tedious. Synthetic division. Ooh, synthetic division, that's the fun one. This is a kind of a shortcut method of dividing. And it only works with binomials. So, in other words, things like x minus 2 or 3x plus 7, things along those lines, okay? If you've got an x squared in there, you can't do it, okay? But synthetic division is if you have smaller binomials and not, x to the fourth plus 2x minus 3, dividing by something like that. With that, you have to use long division. But we're going to be talking about polynomial division now, and we're going to use it again a little bit later in the year, but synthetic division we're going to be using a lot. All right? And you'll get quick at it. It's just a pattern to use. You'll get really, really fast at it. All right? So here we go. Let's slide down a little bit. Divide polynomials real fast. Just again, real quick recap. Don't necessarily write this down, but if you've got, let's say, 3 divided into 498, well, how many times does 3 go into 4? Once. 1 times 3 is 3. Then what would you do? You subtract. 4 minus 3 is 1. Then what? You drop the 9. And you keep going. Same idea. 3 times 6 is 18. Drop that down. You get 1. Drop the 8. Oh, look, this goes in evenly. 3 times 6 again is 18. The remainder is 0. All right? Okay, so y'all remember this, vaguely at least? It's the exact same process. Erase all that, but with polynomials. So, let's start here. I'm going to zoom in so I can write a little clearer. I'll use blue. So we got x squared plus 4x minus 2 divided into x to the third plus 7x squared plus 10x minus 6. All right? We're dividing into that. So here's the deal. You don't have to think about the entire polynomial. All you have to think about is that first term. What do I have to multiply x squared to make it an x cubed? Well, another x squared would make an x to the fourth. We can just multiply it by an x, exactly. Because x squared times x is x to the third. So that's what we're going to put up there. I'll erase those. All right? And then you multiply that by all of those guys, by all of these guys. All right? So x times x squared is x to the third. X times 4x is 4x squared. X times negative 2 is negative 2x. Cool? All right. Now, on regular long division, what would you do at this point? You would subtract. All right. Now, I'm going to do something slightly different because I don't like subtracting negatives. You know what I mean? Kind of like 10 minus negative 2 is really 10 plus 2. You remember that? So in order to keep ourselves from getting too confused, what we're going to do is we're going to switch the signs and then just combine terms. Okay? So if I got a positive 10 and a positive 2, those add up to a positive 12. Okay? If I have a positive 7 and a negative 4, those add up to a positive what?
3x.
So 3x squared. And if I have an x cubed and a negative x cubed, those add up to 0. Those cancel out. So if your first term does not cancel out, you have done something wrong. Okay? You either need to multiply by something else or you multiplied wrong in the first place, whatever. Something along those lines has happened. All right? Any questions about that? Yes, sir.
Why 7 and 4 you get 3?
Okay, so 7 minus 4 is 3. Remember, we changed all the signs. So 7 and a negative 4 add up to a positive 3.
Oh, you changed the sign?
I changed the sign, so I don't have to think subtract. I can think add. All right? Which, 7 minus 4 is 3. That's easy. X cubed minus x cubed is 0. That's easy. What gets crazy when we start doing 10 minus negative 2, well, that's really a 10 plus 2. That's really what it's to save you from, is from subtracting negatives, especially if you had like a negative 10 minus a negative 2. That starts to mess with your head a little bit. All right? And the easier we can make this for your head, the better. All right, so what would you do next? In regular long division, what would you do next?
You do the second number?
What number are you talking about?
4?
Well, okay, so we've subtracted. See if y'all can figure out. We subtracted, so we got our new piece down here. What are we missing? What do we put right here? The negative 6. You drop the negative 6. And then you do it again. Okay, so here we go. X squared times what will get you 3x squared?
1.
Well, do we have to multiply? Do we have the right exponent?
No.
They both have x squareds.
Yeah.
Well, what about the coefficient? What am I going to multiply that 1 by to make it a 3? 3.
3.
Because 3 times 1 is 3, right? So here we go. Positive 3. So 3 times x squared is 3x squared. Then multiply the next one. 3 times 4 is 12. And the x comes along further right. What's 3 times negative 2? Negative 6. All right. And then to keep brains from going overload, I don't like doing it either, we'll switch our signs. Put a negative right there. And we'll add. So what is negative 6 plus 6?
0.
0. 12 minus 12?
0.
0. 3 minus 3?
0.
0. So you have a remainder of 0. So your answer is what?
X plus 3.
X plus 3. Cool?
Yep.
It's just a little tedious. The hardest thing about this is keeping your sign straight. It really is. The hardest thing about this is keeping your sign straight. All right? Any questions? All right, let's do another one. Letter B. Same idea. Now, letter B has a hidden little snag in it. Okay? In order to divide, whatever my highest exponent is, I need to have a coefficient for every exponent underneath there. So I got x to the 4th, x to the 3rd, x to the 1st, and then I got my constant. I am missing the x squared, right? So what is its coefficient if I'm missing it? Zero. 0. You have to have every exponent up there. All right? And now, that is depending on what you have. If you have an x to the 3rd, you have to have a second, a first, and a constant. If you have an x to the 7th, you have to have a 6, 5, 4, 3, 2, 1, and a constant. That sort of thing. Okay? Everything below the highest exponent. So we'll add that 0 in there kind of as a placeholder. So we got x squared plus 3x plus 2. And we're going to divide that into 2x to the 4th plus 3x to the 3rd plus 0x squared plus 5x minus 1. Okay? But hopefully the reason I put in that 0 will be apparent in a minute. But if nothing else, you need it as a placeholder. All right? Any questions? All right, let's get rolling. So, this x squared, what do I got to multiply it by to make it a 2 out front?
X squared.
I got to multiply it by a 2. You're right.
Oh.
You're right. What about the x to the 4th? What do I got to multiply the x by to make it an x to the 4th? and x squared, exactly. So here we go. 2x squared times x squared is x to the fourth. Good. All right. Then go on down the line. Do the 3x. What is 2 times 3? 6. X squared times x is x to the third. All right, do the 2. What's 2 times 2? 4. And x squared just kind of comes along for the ride in this case. That's not a third. It's supposed to be a squared. Okay? And now at this point, hopefully you can see why I added that 0. All right? Because you need to combine it with another x squared. Otherwise, you'd be combining it with the 5x. You follow me on that? That's why you do that. So, what's next? Well, before we bring it down, what are we going to do? Has to do with the signs. Switch the signs. Go ahead and switch them. Now, if you don't want to switch them, that's okay. You just got to remember you're subtracting, so you got to get all your signs right. Okay? So again, your first one cancels out. What's 3 minus 6?
Negative 3.
Good, so negative 3x cubed. What's 0 minus 4?
Negative 4.
So negative 4x squared. Cool. What do you do next? Drop the 5. Good. And that's the pattern. We're going to do it 2 more times. Once for the 5x and once for the negative 1. Cool. However many ones you got, that's how many you got to do it for. So, this x squared, what do I need to multiply it by to make it a negative 3x cubed?
1x squared.
Okay, we got to well, we're going to make it a negative 3. Focus on the coefficient and focus on the exponent.
Negative 1x.
Okay, hold up.
No, 3.
This is a 1, right?
Yes.
I got to multiply it by a negative 3.
Negative 3.
Do I need to multiply it by an x to get it up to an x cubed?
X squared.
Well, an x squared times an x squared is an x to the
4.
the fourth. We need an x to the third. So we just need to multiply it by a single x. Okay? All right. So multiply it out. What's negative 3 times 1?
Negative 3.
What's x times x squared?
X cubed.
Good. Move to the next one. What's negative 3 times 3?
Negative 3, negative 5.
X times x is?
X squared.
All right, do the 2. Negative 3 times 2 is?
Negative
6.
I wrote a negative 3. And the x comes along for the ride. Cool?
Okay.
I'll move it up. And flip your signs and go. So it's a positive 3x, positive 9x, positive 6. The x cubes cancel out. How many x squareds do you have? 5. 9 minus 4 is 5. 6 plus 5 is?
11x.
11x.
Mr. Hunter,
What's up?
I have a question. How do you get the 3 on negative 3x third?
You talking about this one right here?
No, the other one.
This one?
No,
This one.
yeah.
Okay, how did I get this?
But the,
All right.
No, the small one.
This?
Yeah.
Okay.
You
X
have one there.
times x squared.
Yeah.
X times x squared is x to the third. Okay?
X squared.
Is x to the third. You can think of it like this way. This is an x to the 1. All right? We just don't write it. And when you're multiplying your x's, you just add the exponents. So this is a 1 plus 2 gives us a 3. Just like a 2 times 2 plus 2 gave us a 4. You follow me?
And 3 times 3 it gives you 6.
3, well, if you got an x cubed times an x cubed, you would have an x to the 6th, exactly. All right? All right, so let's keep rolling. So I got a drop your negative 1. What am I going to multiply this one by? Let me ask you this. Do we have the x squared already? Yeah, so we need to multiply x. How do we get the 5? All right. What do I need to multiply my leading coefficient by to make it a 5?
By 5.
By 5. Okay? All you got to do is focus on the first one. That's it. Why? Because the rest of it will kind of come down to on its own. All right? You need to worry about the biggest one, and the rest of them will figure itself out. I probably should not be sitting down in this seat. Oh, yeah, whatever. All right, so what's 5 times x squared?
5 squared, x, 5x.
What's 5 times 3x?
15.
What's 5 times 2? Okay. All right, what do we do next?
Change sign.
Change the sign, so that's a negative 5x, a negative 15, and a negative 10. Then what?
They cancel out.
First one cancels out. 11 minus 15 is?
Negative.
40.
Yeah.
Good. And negative 1 minus 10 is negative?
11.
Negative 11. Okay, so this one has a remainder. Cool?
Uh-huh.
Here's how you deal with a remainder. You take your answer, 2x squared minus 3x plus 5, and the remainder just gets tagged onto the end like this. Negative 4x minus 11 divided by x squared plus 3x plus 2. Okay? It just gets tagged on like that. Because I can't continue to divide it, I just have to show this is what's left over. All right? Does that make sense?
Yep.
I just took my remainder, I took my answer, and then I added on my remainder divided by my quotient. Cool?
Yeah.
All right, how are we doing this? Give me a 5 to 1. 5, I got this. 4, I'm okay. 3 and 2, I'm lost. Sweet. Try letter C. First things first, do you have to add a 0 for letter C?
No. Yeah.
Did you look at it?
Yes, we do.
Where?
On the x squared.
On the x squared for letter C?
X cubed.
Well, do you have all of the exponents represented?
Yes.
Yeah.
Yeah.
3, 2, 1.
I got a 3, I got a 2, I got a 1, and then I got my constant. So do we need to put a 0 in there?
Oh, no.
No, you do not. All right, so go for it. Okay, you got the x cubed. What goes next? Yeah. So you did x squared times x to get x cubed. You did x squared times 9 to get what?
Oh. That one is it?
Yeah, what's that?
Minus one.
Sure.
How should I do like all of them?
Mm-hmm. You multiply that x squared by all of whatever you're dividing by. It's kind of like when we're dividing, we did a lot, just with the numbers. Like if you had an 8 here and it went in 3 times, 3 times 8 is 24, and then we subtract. So that's something I got to multiply this by all of that, and I get that. Cool. You all right? I'm sorry. Cool. Perfect. If it came out even, you probably did it right. X squared times 9 is... Since you only have 2 terms out here, you're only going to have 2 terms right there. You just add those 2.
Mr. Hunter.
I did x squared times both of those. X squared times x is x to the third. X squared times 9 is 9x squared. And then when I subtract, I'll flip the signs and just combine the terms.
Oh, is it?
Good. Come on, wake up on me. Wake up. Got it?
Yeah.
All right, well, let's see if I can put it up there, see if this works this time. There we go. Oh, God. X squared plus x plus 4. What you should have got. Come on, Jack. Start with 1 up. All right. Any questions on this? I saw a number of individuals that were doing stuff like this. They would take the x squared and they would multiply it by the x to get something, the 9 to get something, and then they would do it again to get a third one over here. All right? There's only 2 parts to this binomial, so when you multiply it, you should only get 2 parts right there, so that when you subtract, all right? There's only 2 pieces out here, you're only dealing with 2 pieces at a time. What did I get this for? Okay, that 4 right there, basically what I did is I took this x right there, and I said, when I got this one right there, what am I going to multiply this by to get 4x? The x is already there. Well, x times x squared is x cubed. X times what is 4 times x? 4. I just have to multiply this by 4 to get a 4x. Does that make sense? All right. So I did 4 right there, because 4 times x is 4x. And then I carried on. 4 times 9 is negative 36. It's positive 36. Cool. So each time, all you need to look at is this first term and whatever the first term is of your set. So in this case, the x cubed, then the x squared, then the 4x. And then if we were to keep on going, you'd focus on this term. Cool? All right, if you're still writing, finish up, but go ahead and turn the page. We need to deal with the next section. All right, that's long division. All right, and that's arguably the more tedious and the harder of the two, simply because it's easier to make a mistake and there's more steps to it. All right, this one, there's really only 3 steps. But remember, this only, come on, only works with a binomial, i.e. things like x plus 2 or x minus 7, things along those lines. It only works with a binomial. So if we were dividing by like x squared something, it would not work anymore, okay? So, here's the pattern. Oop,
Mr. Hunter,
let's get this in the right spot. What's up?
sorry. I was trying this one.
For this one, we're going to start off by taking this x minus 3 and set it equal to 0. So we'll go to x minus 3 equals 0. So I move the 3, x equals what? 3. Okay? That's the number I'm going to use. All right? From here, I need that number, and then I need all the coefficients. Okay, so the -1, the 4, and the 9. Now, do I have to add a 0 anywhere?
Well, yeah.
Where?
After
After the what?
the x.
After the x squared. Good. There should be a 0 added right there because I got the x cubed, I got the x squared. I don't have the x. So your coefficients are -1, 4, 0, and 9. That 0x really is there. We just don't write it because it's 0. Okay? So we need what we're dividing by and the coefficients. Cool? That's the setup. From here, here's the process. We're going to drop the first term. Don't write this down. Just watch. We're going to drop the first term, then we're going to multiply by 3, put it there, add. Multiply by 3, put it there, add. Multiply by 3, put it there, add. Multiply by 3.
What?
And we will just keep on following that pattern until we are done. Okay? So let's do that again. Basically, here's what I'm saying. We're going to drop the first term, multiply by what's out front, then add. Multiply by what's out front, add. Multiply by what's out front, add.
0 times
Okay.
3.
So here we go. Just follow with me. So first things first, if I drop the first one, I get a -1, right? Cool. What's -1 times 3?
-3.
-3. Okay, so that's the first multiply. Now add. What is 4 minus 3?
-1.
No, just 1.
Oh, 1.
Okay. So now multiply again. 1 times 3 is 3. Add them up. 0 plus 3 is 3. Multiply again. What's 3 times 3? 9. 9 plus 9 is 18. That's the whole process.
And that's it?
That's it. I took this one, I dropped it, then multiply by 3, add. Multiply by 3, add. Multiply by 3, add. This, the 18, is my remainder. All right, DER. And then these are my constant, my x, and my x squared. So your final answer is x squared plus x plus 3 plus my remainder, which is 18 over x minus 3. Okay? That's the whole pattern. Okay? So you got to set it up. Don't forget your zeros. And then the pattern is drop the first one, multiply, add, multiply, add, multiply, add, multiply, add, multiply, add. Keep doing that until you are done. Cool? Let's do another one.
What you did to
Let's keep rolling. All right, the next one. Take your term. We're dividing by x plus 1. Set it equal to 0. X plus 1 equals 0. So what number are we using? -1. Good. So that's the number I'm going to multiply by all the way down the list. Every time I multiply, I'm going to multiply by a -1. All right? Do I need to add a 0 for any of my coefficients? No, I got an x to the 4th, the 3rd, the 2nd, the 1st, and my constant. So just take all your coefficients. That's 3, 1, -2, 2, and -5. All right? Then it's drop, multiply, add, multiply, add, multiply, add. So I'm going to drop which number? The 3. Drop the first one. 3 times what? The -1. 3 times -1 is? -3. Combine those two. What's 1 and -3 add up to? -2. -2 times -1 is? +2. Add them up. You get? 0. 0 times -1 is? 0. Add them up. You get? 2. 2 times -1 is? -2. Add them up. You get -7. 7. So what is your remainder in this sense?
7.
No, -7. Don't drop your negatives. It's all right. -7 is your remainder. And then that's your constant, that's your x squared, and your x cubed. You will notice that, and this has been a hard one for everybody, we start off with an x to the fourth, we'll end up with an x cubed, okay? I've had a lot of people go, hey, there's an x fourth up here. Why doesn't my answer have an x fourth in there? Because we divided out an x. That's why. So you will always go down by at least 1 index, 1 degree. I'm sorry, not index, degree. So your answer is 3x cubed minus 2x squared plus 2 minus 7 over x plus 1. And yes, believe it or not, oops, wrong, I picked the highlighter instead. That is really a 7. Cool?
Yep.
What's up? We'll talk in a minute. Any questions about this at all?
Wait. I didn't just put +2.
How did I put +2? Well, here's the deal. I got a 0 right here, right? Do you ever write plus 0x? No. It would just be like writing +0, so I don't need that. All right? I need it when dividing because it's my placeholder. But I don't need it when I actually write my answer. Cool? All right, good question. All right, let's keep rolling.
X.
I'll leave that right there. Letter C. All right, for letter C. When you multiply in this case, what number are you multiplying this time?
2.
Positive 2. Good. You took the x minus 2, you set it equal to 0. All right. Do you need to add any zeros to your main polynomial, what you're dividing it to?
No.
No. Okay. So set it up and solve it. Set it up and solve it. All right, I think it's time to put it back up there. Here you go. You get x squared minus x minus 9, and you get -12 as a remainder.
Yes, sir.
Oh, yeah.
Yes.
Did you put the -12 over x minus 2?
Yes.
Good.
Oh, yeah.
Because you got to put your remainder over whatever you were dividing by. Now, I put the negative out front in front of it. You can either put the negative, here, let me zoom into it real quick. You can either say negative out here like that, or you could say plus -12 over x minus 2. All right? They mean the same thing. It does not matter which way you go with that. All right? I'm just used to putting it out front because that's what it is. All right? Cool.
Yep.
All right, let's go. That's one use of synthetic division. If you're dividing by a binomial, you can use synthetic division to get your answer real quick.
I have a question.
What's up?
What happened to the x cubed?
What happened to the x cubed? Remember, we divided by an x. So your x cubed went down to an x squared. Okay? All right, so let's look at the next one down. The remainder theorem. The remainder theorem basically says if I use synthetic division, whatever I'm multiplying by is my x value. Whatever my remainder is my y value. It gives me a legitimate point on the graph. So for letter A, they gave me the x value of -4. So do I need to flip that -4? No, I don't. They didn't give it to me like a factor. They didn't give it to me in a binomial. They just say, hey, x is -4. So we're just going to, let me spread out. We're just going to go straight, -4, and then fill it in. Do we need to add any zeros? No. So 5, -1, 13, and 29. Yeah, this one's going to look a little big, but so what? So what's step 1? What are you going to do? Bring down the 5. What's 5 times -4? -20. What's -20 minus 1? All right. Anybody know what -21 times 4 is?
81. 84.
84. Good. 4 times 2 is 8. 4 times 1 is 4. So is it negative or positive?
Positive.
Positive 84. Good. Add them up. You get 97. Anybody know what 97 times -4 is?
Wait, let me see.
Yeah, I don't know how to do this in my head either. Somebody do it with a calculator.
I can.
Negative 388? Yeah, I think that's right. All right, combine them, you get negative 300 and what?
I think it's 4.
Goes the other way. You went the wrong way. It's negative 388 and a positive 29. So it's becoming more positive, not more negative.
Negative 361. 59.
Negative 359.
That was close.
Cool. So, for this polynomial, when x is negative 4, y is negative 359.
That's it?
That's it.
Oh.
They're using synthetic division to evaluate the polynomial at a specific point. So if I know x is negative 4, rather than going, okay, negative 4 to the third power, that's negative 64. Negative 64 times 5 is, dear God, something big. Subtracting negative 4 squared, which is 16. So subtract 16 plus 3 times negative 4, which is negative God knows what. I'm already got a headache on this.
So,
Okay.
Mr. Hunter, you just left the negative 4 and the biggest one?
Nope, the remainder.
Oh, the remaining?
It's the remainder. Your answer is whatever you were multiplying by out here and your remainder.
Oh, that is easy.
It is easy. So if they tell you to use synthetic division to evaluate, that's all you're doing. Grab your whatever you're multiplying by, grab the remainder. All right? So letter B. Do you have to add a 0 to this one? No.
Oh, no.
No, you got an x squared, you got an x, and you got a constant. Fill it in, set it up, knock it out. Turn my recorder, there we go. And you should get 529. All right, how are we doing with the whole synthetic division thing? Give me a 5 to 1. 5, I got this. 4, I'm okay. 3, 2, I'm lost. 1, save me.
I'll give you a 10.
Sweet. One more thing and then we'll move on. I want to address one more thing. Turn the page. Go letter C. Letter C. Hold your answer to yourself for a second. Don't answer it immediately. I want you to think, do you need to add a 0? Don't yell it out. All right, for letter C, do you need to add a 0? No. Good. The highest one is a 3, and then we got a 2, a 1, and a constant. Okay, don't yell it out again. Letter D. Do you need a 0? Don't yell it out.
I say yes.
All right, letter D. Do you need to add a 0?
No?
Yes. Which one do you need the 0 for?
The 2x squared.
The x squared. Good. We got an x to the 4th. We got an x to the 3rd, but we got an x. We're missing that 0x squared right there. So when we set it up, it's 2, 5, 2, 0, negative 20, negative 6. And go from there. Cool? Any questions, comments, complaints, public service announcements, quibbles, limericks, stupid jokes? All right, done.
I know, ready.